finding the area and the centroid of a 2D shape using the single integration method. When we have a shape defined by a functional relationship, that is, a relationship between x and y for the curve of the shape, we're going to be able to find its area and its centroid with a single integral. And I'll note you can use a double integral method as well. That will be outside the scope of this course. But when using the double integral, we have to be careful on what the bounds of integration are if we apply that. But we're going to go with the single integral method. In this method, we're going to use horizontal or vertical rectangles or strips that are going to go across our entire shape. And the use of a horizontal versus a vertical rectangle is going to really depend on how the function is described. What's the relationship between x and y? Always a horizontal or a vertical rectangle will work for a shape, but it could be that the calculus we have to do, the integration we have to do, is trickier using a vertical versus a horizontal or vice versa. So if we choose to go with vertical rectangles or strips across our shape, that means that we are going to put everything in terms of x and dx, and we'll see what that means as we go into the actual equations on the next slide. If we go with horizontal strips or rectangles, that means we're going to put everything in terms of y and dy. So this is what is going to distinguish this single integral method versus a double integral method, is right from the start we're only going to have things in terms of a single variable. So we only have to do a single variable integral. So what we want to look for vertical versus horizontal is usually, is there an orientation of these strips that's going to avoid using a radical, a square root, a cube root, something like that. Because when we're solving these by hand and we're doing an integration, it's going to be just harder by hand to integrate something that is the square root or a cube root rather than something that is raised to a second power or a third power. Again, when we see some examples, we'll see the choice that we have. Is it better to put things in terms of the x or the y? So when we break our shape into these horizontal or vertical strips, we need to find for any strip, kind of generically as a function, what is the height of any one strip and what is the width of any one strip. So always one of these dimensions is going to be infinitesimally small. If we're making vertical strips, that means that every strip has a very, very tiny width of dx. If we're using a horizontal strip, then every strip has a very, very small height of dy. Now for that remaining dimension that's not the infinitesimally small one, we're going to need to know in terms of the x or y, what is the height of every one of these strips. So we need to know where the top of any one strip is located and where the bottom of any strip is located. Once we can describe the height and the width of every one of the strips, then we're going to be able to find the area of each strip. The area of a single strip will be referred to as dA when we get into the calculations, but really we are going to be, when we're doing the integral, using some function of x times dx or a function of y times dy, depending on horizontal or vertical strips. So this calculation will become a single variable integration. Once we know the area of any one strip, we're going to be able to find the total area by integrating or totaling the area of every one of these infinite number of strips together. Then we can go on and find the centroid. So what we can do is we can find the centroid of every strip. So again, generically finding what is what I'm going to call x tilde and y tilde, the centroidal location of any one strip. And what we want to do is we want to measure that distance from the coordinate axis. We're always going to be measuring this from our common origin for the shape. So every little strip is going to be measured from the same origin. So since we're making every one of these strips as a rectangle, the center of a rectangle is going to be located at half of its height and half of its width. So we want to find out how far is that point for any one of these strips from the origin. So what do these calculations look like? Well, the first thing we're going to do is again calculate that total area of our shape, and we do that by adding up all the areas of the strips. So each strip has an area of dA, And what an integral does, since we have an infinite number of these strips, an integral does basically an infinite summation. So we're totaling up the area of all infinite of these little strips. And when we do that, we get the total area of our 2D shape. And that's what A is. Once we know the total area of our shape, then we can find the centroid of our entire shape. And we're going to do that by using those x tildes and y tildes that we've defined. So the x tilde is again the centroidal location of any one strip and in the x direction, and y tilde is the centroidal location in the y direction for any one strip. So basically in this step, to find what I'm going to call x bar and y bar, which is the centroid of the entire shape, we're more or less doing a weighted average of the centroids of all of the strips that make up our shape. So what we do is for every strip, we're going to multiply where is its centroidal location times its area, and we'll add those all together. And then that result, that integral, is going to be divided by the total area of the shape. And we do the same thing in the x direction and the y direction to find for the whole shape its centroidal location. So once again, we can think of it as the weighted average of the centroids of all of the strips that make up our shape.